All right, today we're going to talk about comparing, ordering, and rounding numbers. Now, the numbers that we're talking about are really decimal numbers. Okay, you'll have a few whole numbers that you're comparing, but most of them will be decimal numbers. Let's remind ourselves what the decimal place values are. Your decimal place values, okay, if we start with the decimal here, the first one you have is the tenths. Okay, then you have the hundredths. Then you have the thousandths. Then you have the 10,000ths. Okay, that's the first few place values to the right of the decimal. Obviously, to the left of the decimal, it's the ones you should already know, the ones, the tens, the hundreds, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths, 100 millionths, so on and so forth on those. But mainly the ones that we're going to be dealing with today, we're going to be comparing decimal numbers. Okay, rarely will you have any just whole numbers in comparing them. So we need to make sure that we understand those place values. Most of the time they're going to either underline the place that they want you to round to. They will rarely say, round to the tenths place. They will on a couple of them, but the rest of them will be, underline things of that nature. So, as we're talking about then about comparing and ordering numbers, okay, the first thing you do when you're comparing or ordering numbers the first thing you're going to do is line the numbers up vertically with their decimals. Okay. The second thing you're going to do is make sure that all numbers have the same amount of digits to the right of the decimal by adding zeros. And I'm going to go over both of these steps. I just want you to get them written down. Zeros. All right, now, so for example, if I'm comparing these two numbers, 6.5 and 6.45. Now, for some of you that may be very easy to see which one's bigger, and that's fine, but I want to show you the steps. First step is to take the two numbers and align them vertically by their decimal. So in other words, line up that decimal right there. Okay? Secondly, I'm going to make sure they both have the same amount of digits to the right of the decimal. Well, this one has 1, this one has 1, 2. So I've got to add a 0 right there. Okay, now it should be fairly simplistic which one is larger, but what you do is you look at the first digits. They're the same. You look at the second digit. Which is larger, 5 or 4? 5. So therefore, we're going to put in here the greater than sign. Okay. The other way you can look at it is, if you look at 650 and 645, obviously 650 is the larger number. Okay? Once you've put the same amount of digits, it's that way. Now, understand that just because a number, for example, let's say I'm comparing these two numbers. 1.1 and then 1.098765. Just because a number has more digits does not make it bigger. Okay? That would be like saying I take I take 0.9 and then I have 0.000000009. Well, that's got more digits, so it's got to be bigger. No, it's smaller. Okay? So don't just assume that because one number has more digits that it has to be larger. It can be, but it doesn't have to be. So if we look at this one here that I did, 1.1, and then I'll line up the other number, 1.098765. Okay, now, if I add the same amount of digits to each number, that means I have to add zeros here. Okay? And if we look at the first digit, it's the same. If you look at the second digit, the 1 is bigger than the 0, so therefore we have the greater than sign again. Okay? Now, let's look at this number. Okay? How do we write this number in word form? How do we write that number in word form? Tayshawn. Thousands, yeah, but you got to finish out the number. Yes, that is what the last place value is thousands. Levi, help him out. 7 and 86,000? Yes. 7 and 86, obviously when you spell that out, not just write it in numbers. 86 thousandths. That's how you would write that number in words. You must identify this last digit here, what place value it's in, so you can have the correct word at the end of your explanation. Okay? Now, I'm going to look at number 18 says, I want you to do those 4 problems. remember that your two signs, that's is less than and is greater than. So on number 18, Tristan, what goes in the blank? The less than or the greater than sign? Greater than. Okay. 19, Cameron. Greater than. 20, Brandon. Okay. 26, Trinity. Less than. Okay. So, those are those four. All right, now, let's look at ordering. Okay, we'll get to rounding here in a second. Ordering, if I give you these numbers, 1.2, 3.2, 0.2, and 0.9. Okay, those are my numbers, and I want to put them in least to greatest order. Well, the first thing is still stack them vertically. Make sure they have the same amount of digits to the right of the decimal. Do they have the same amount of digits to the right of the decimal? Yes. So now we look at this first set of numbers. I have 0, 0, 3, and 1. Okay. Well, 3 and 1 are larger than 0 and 0. So which is larger, 1 or 3? 3. So I'm going to put 3.2 as my first one. My second one then is 1.2. Those two numbers are gone. So now I just look at these two numbers. Which is larger, 2 or 9? 9. So 0.9 is next. 0.2 is last. So 0.2 is the smallest or the least. 3.2 is the largest or the greatest. Trinity?
Remember last year how you said that sometimes you didn't want it to be greatest to least?
Yeah, they won't do that in this book. This book will always be least to greatest. Because they're not trying to confuse you. The other book, I guess, was trying to confuse you. But yes, I do remember that. Because we just actually had it the other day in 6th grade. Okay, so these are always going to be least to greatest. Okay, I want you to try this one on your own. A little bit more difficult. 4.3, 4.03, 4.27, and 4.23. So put that one in least to greatest order. All right, Erica, what'd you get? Yep. That is correct. Excuse me. Okay, so that is from least to greatest right there. Okay. Obviously, I would suggest, like we've been talking about, list them vertically in their original form, lining up the decimals. Okay, you would add a 0 here, obviously. The 4s are all the same. Then you get to the next one, you have 3, 0, 2, 2. So this one's obviously the smallest. Okay, then you have 2, 7, and 2, 3, so that's second. That's third. That's fourth. Okay. Now let's talk about rounding. Okay, the rules for rounding. Number 1, circle the number immediately to the right of, let's change this to circle the digit. Immediately to the right of the marked digit. So that's the first one. So for example, if I had this right here, 12.0092, and they marked the thousands digit. Okay, then we're going to circle the digit immediately to the right. Okay, now, step number 2. If the circled digit is less than 5, the marked digit stays the same. Step 3, if the circled digit is 5 or greater, then increase the marked digit by 1. All numbers, let me put that in there, step there. Step 4, all numbers, keep using numbers instead of digits, all digits to the right All digits to the right of the marked digit turn to zeros. So, in our example of 12.0092, okay, the number that is circled, is it less than 5 or 5 or greater? 5 or greater? Cameron. Okay, it's less than 5. 2 is less than 5. So therefore, what do I do to the 9? Stays a 9. So you end up with 12.0090. Okay, but since that 0 at the end is behind the decimal, I don't need it. And so my actual answer is 12.009, and that's your answer. Give you a second to finish writing that down. Yes, Gabby.
So, if, like, so only the 2 digits to 0? Wait, like, okay. So
Any numbers to the right. So if I would have had this, let's say it would have been 12.0092, and they would have marked that number. Okay? Then I would circle this number. Okay? That keeps the 2 the same. And so the rest of the numbers from here would turn to zeros. Okay? Now, I would not need those zeros there because they're behind the decimal and they have no effect on the number. Okay? I do, however, have to have these zeros here because, yes, they are behind the decimal, but there's an actual number or digit past them that has to stay in that place. So I can't mark them out here, but I can mark them out here because they don't have any effect. If there was this by chance, if it was a 1 right there, then I would have to keep all those zeros. Okay? Or if they were on, let's look at another one here. Let's say I had this and it was 198,452, and they underlined that 9. Okay? Well, that means I circle the number immediately to the right, which is an 8. Well, what happens to the 9 if it's greater than 5? I increase it by 1. So if I increase 19 by 1, what does that give me? 20. So this would be 2, 0, and then everything here turns to 0, so it would look like that. Now, I have to keep those zeros. I can't mark those zeros out because if I mark those zeros out, then I have 2. And 2 and 200,000 are not the same number. Whereas 12.0000 and 12 are the same number. That's why I can mark them out on the other side. Okay? Any other questions before I move on? All right, I want you to round this one 32.09, and I want you to round it to the nearest tenth, which is this digit right here. So round 32.09 to that digit right there. Kennedy, what'd you get?
32.1.
That is correct. 32.1. We circle this number here. Okay. That number is greater than 5. So I add 1 to the 0. 0 plus 1 would be 1. So that would be 32.1. And that is your answer. Now understand, it would have looked like this. But once again, we don't need that 0. Okay, and so that's your answer. All right, your homework, or your work that's due on Monday that you still have about 10 minutes in class to do, it is a fairly long assignment. Okay? But it's also not very hard. There's not a lot of mathematical operation to it. Yes? I will count it wrong in this lesson. The reason being is because if I am rounding to this digit, that's the digit I rounded to. Well, by my answer, I actually rounded to that digit. You weren't supposed to round to the tenth. You were supposed to round to the tenths, and you actually rounded to hundredths. Okay, so I don't know if there was a 3, a 2, or a 1 behind that 0, and you just kept the 0 as 0, so it's not rounded to the proper digit. So yes, in this lesson, we will count it wrong. Is it mathematically incorrect in the sense of the number? No, but it is when you're rounding. Because when you're rounding to a certain specific digit, and therefore you can't have extra digits at the end. All right, your homework is 2.1, 6 through 42. Okay, now, like I said, that is due for y'all tomorrow, I believe. Let me look here. No, it's actually going to be, I'll actually do a part of it in class tomorrow. Okay, so it's not homework in the sense of, it's due tomorrow in the sense of right when we begin class. We'll probably spend about 20, 30 minutes in class doing it, and then I'll cover the next lesson, okay? So you need to get working on it right now because you still have about 10 minutes left in class, okay? You will not do it for homework. We'll finish it up in class tomorrow. So get started. Now, if I see you not work, then it will be due at the first of class tomorrow. What, Brandon? Huh? Can't wait 10 minutes? If you can wait 10 minutes, that saves you a mark. If not, you're more welcome to go.